Hey guys, so in this video, I will be continuing our discussion on Java. In the previous video, we created the dog file, which was a pretty basic introduction to what we'll be doing in this video, in that we'll be implementing a lot more methods. So what I want to do is go back to our UML diagram, and I actually updated the Panda class to reflect what we want out of the Panda class. And before we go into this, let's just quickly review the dog class and what we did. So as you can see, we have name, months to finance, and price as the variables that we'll be using. And they are private, as you can see with the negative signs. And after making these variables, we also created the constructor for the dog. So this is going to be what happens when we create a new instance of this dog object. So for example, if we do dog, and let's call it something random, let's call it gym equals new dog, and then according to this constructor we have to pass in these variables. So let's call it its name gym, and then let's think of a price. Let's say it's $4.50, and months to finance, let's say it takes 12, the user wants 12 months to finance the price of this dog. So this effectively makes it so that Jim can now access all of the methods that are instantiated within this dog class. So if we want to do calculate monthly financing, we do gym.calculate monthly financing, and that will return price divided by months of finance. And these two variables are defined in this constructor we created. So it would be 450 divided by 12. And if we go to Spotlight and do 450 divided by 12, we expect to get 37.75 for this method. And likewise, we can do that for this, where we do gym.calculate monthly financing, and then let's put an arbitrary tip. So let's say we give the person who helped us find the pet $30, then we will return this amount, which is price plus tip divided by months to finance. And the best way we can prove that these methods work is by creating the dog test.java. And as you can see, we created a new instance of the dog, and we called it right here. So private dog Marty, and Marty equals this price and months to finance. And we basically did what I just showed you here, in that we test out the methods. So Marty.calculate monthly financing is the actual, expected is what the method is actually doing, and then we do assert equals actual and expected. So we're basically comparing the values of actual and expected and making sure that they're equal. And we're doing that same thing for calculate monthly finance with tip. And then we do a negative test where we try to pass in a value that isn't expected and make sure that we get some sort of buffer that allows us to identify that that's a value that shouldn't be passed in. So for example, in dog.java, we create this if condition that if price is less than 0 or months to finance is less than 0, we return 0.0. And that's what this test tests for, is if you get a negative value, it'll return 0. So we did all of that in the last video. And actually, before we even go on, let's run this. So let's run this test and show that we get the values that we expected. And as you can see, we have all three tests passing because the actual and expected are matching for each of these methods. So now that we've reviewed that, let's go into the panda.java class, and I want to implement this stuff. And so let's do that right now. This is very similar to what we did for the dog class. So let's do class panda, and let's create the variables. So private name, private string name, private int months to finance, and private double price. So we can actually copy and paste that for the sake of time from the dog class. And now we also have extra variables. So we have expert visit per month, special vet fee per month, and habitat expert fee. So these are variables that we have to create because we're going to be using them in these methods. Now, why do we have these variables here, but we don't have these variables instantiated in the dog class? Well, this is because pandas are exotic animals and they have special needs that needs to be accounted for that a regular dog really doesn't. In that, for example, an expert from the local zoo will visit your panda every month to make sure that he's safe and he's not, you're not doing anything illegal with trafficking the panda or whatever. And he also gives you tips and nutrition tips and like what he should be eating and where he should be living, etc. So we have that visit per month as $250. And we actually created this number because a panda, no matter what type of panda it is, will always have a fixed $250 per month for an expert to visit. Likewise, we have the vet fee. So we have a specialized vet that takes care of your panda. And these are all mandatory fees, by the way, that you have to take by buying the panda. And this will cost $320 per month. And then the habitat expert fee. Note that we don't have a per month at the end of it because this is the total lump sum pay that you have to pay for a habitat expert to come in and make sure that the habitat that he's living in is sufficient for his survival. And we also have an animal habitat expiry date. So this is the date that by the local government law you have to have the habitat expert come in. So today from me it is March 21st, 2021. And so even if this you buy this panda like 2 months later, this expiry date will still be 10/22/2022 because that's when the law expires basically. So that's why we also created a fixed value. And note that LocalDate.of will make this variable of type LocalDate because you're converting what could be considered a string into LocalDate by using this LocalDate.of. So let's do that right now. Let's create all these variables that I just mentioned. Private double expert visit per month equals $250. Private double special vet fee per month equals $320. And private double habitat expert fee equals $2,000. And then finally, we also need that private local date. So private, and then it's going to be local date. Note that we capitalized the L and the D. And then animal habitat expiry date equals, and then this is what converts this from a string or integer into local date. So 10/22. And now we have errors that are saying that local date cannot be resolved to a type. Well, we have to import it. So Eclipse will automatically solve these errors. So import local date, and we have that right here. And then the errors are resolved. Now we have the variables. We need to do the most important thing, which is the constructor. So as you can see, the constructor is identical to the dog constructor. This is a typo. This should be dog. So let's actually copy and paste the constructor from dog into panda. And let's just change this dog to panda. So now we have our constructor, and we don't really need any other instantiations because we're passing in name, price, and months to finance. We're not passing in any of these variables, especially because they're fixed, so you don't really need to pass them in. It's a waste of space. So we're only passing in name, price, and months to finance because these can vary depending on the panda, but these fees will not vary depending on the panda. In that if we create a new instance of the panda, these variables will remain consistent. So now we have the constructor. Let's also create the calculate monthly financing, and this is similar to the dog method, so we can also copy and paste that. So we have this, and that's all we need for that method. And then we have calculate monthly maintenance fees. This is a method that's exclusive to Panda, so we need to create this ourselves. Public, and it's a double, and it's calculate monthly maintenance fees. Okay, so in order to calculate the monthly maintenance fees, we have to add up the expert visit per month, the special vet fee per month, and we have to find the monthly fees for the habitat expert to come in between now and the expiry date when the law no longer applies. So let's do the easy ones first. We return expert visit per month plus special vet fee per month, plus we need to have the habitat expert fee per month. Note that this is more complicated to do because we don't have, this is not the monthly fee, this is the lump sum amount, and we don't really have any method that calculates the fee per month between now and this date. So let's actually create this method. So we have the get habitat expert fee per month right here. So let's implement that. Public double get habitat expert fee per month. So what I want to do is find the time between animal habitat expiry date, which is this variable, and I want to find the time from now. So there's a function we can use, and it's called chronounit.months.between, and you can look this up on Google to kind of understand this more, but I will also explain this shortly. Expiry date and LocalDate.now. Okay, so let me explain what this is. So chrono unit is just a type of package that we need, and as you can see here, it's not resolved because we need to import it. So let's import it right now. So we imported chrono unit. Months is what we want to find the value of. So we want to find the per month. So we want to find the months between the expiry date and now. So this is obviously the expiry date that we defined up here. And LocalDate now is a pretty cool functionality of LocalDate because it will return the local date of today. So today is March 21st, 2021. So it will basically print out March 21st, 2021 in your file. So what we want to do now is make this equal to a variable. So this is going to be of type long. We're going to make an assumption just for simplification. We're going to assume that this file will only work if the date now is before the expiry date. So if we're in November 1st, 2022, then this file will no longer be valid and we have to update it. So we're gonna make this the absolute value between this and this. So in order to do that, we invoke the math package and we do .absolute value and put all of this in parentheses. And that's all we need to do for that duration. So we do this, and then we actually do habitat fee per month. This is going to be a variable, and we need to define it because it's saying cannot be resolved. So let's define it up here where we go double habitat fee per month, and that should resolve this. Oh, we have to complete it. So let's do habitat expert fee, which is 2,000, divided by duration, and duration is this variable right here. So this will calculate the amount you have to pay per month to get $2,000 paid off, because we are dividing 2,000 by the duration between now and the expiry date, which is 10/22/22. So this is this is pretty much done. So what we can do is do get habitat expert fee per month, and giving me an error because I spelled it wrong. Expert fee per month. So before we continue, or actually we're done with the Panda method, let's actually do some tests. And I left out a couple of things in this method on purpose just to show why testing is so important. And we'll be fixing it shortly. But let's go here. Let's go to Panda, right click it, and create a new JUnit test case. We want it to be the latest Jupyter test. We don't really need teardown after, teardown, or set up. We do need setup before class because we want to create a new instance of the object, and I think that's all we need. So let's finish, and we have our template right here. So what I want to do is create tests for each method. So let's start with the easy one, test get habitat expert fee, which is, the calculate monthly maintenance fees. So let's do test calculate monthly maintenance fees. And as we did in our dog test where we had an expected and actual and we compared them through assert equals, let's do that same thing. So double expected equals, so expected is going to be what we want the value to be equal to, and double actual equals. So before we even go on, we have to create a instance of Panda. So let's create a new Panda called Andy. So Panda Andy equals new Panda. His name is Andy. His price is $5,000, 0.25, and the user wants to finance it for 6 months. So now let's do expected, or let's do actual. Let's do Andy dot get habitat expert fee per month, and we'll get an error because Andy cannot be found within this test, so we have to make this a local variable, Panda Andy, and we can delete Panda here, and that will resolve Andy here. And we get an error here that is saying actual cannot be resolved, and that's probably because this needs to be fixed. So let's calculate this out. So expected is going to be $2,000. So let's go back to here. It's going to be $2,000 divided by the number of months between now and 10/22/22. So this is going to be I think 19 months. So let's do that right now. Let's go back to Panda test. Let's calculate this. $2,000 divided by 19. 105.263. 105.263. This is a repeating decimal, or not repeating, but never-ending decimal. So we want to like round it out somehow. And we had an error that's not used, and we're about to fix that shortly with assert equals expected and actual. So we're comparing the value in expected with the value in actual, making sure that they're equal. Let's run this test. Exotic animals data flow. Let's actually see what's going on. We have an error up here. Declared package, so we don't have a declared package, so let's actually fix that by adding com.dataflow to exotic. Note that this package is here because it's all of these files are under com.dataflow.exotic, so we have to specify that this is the package. And we have an error here. This method must return a result of type double, right? Because it is double. So we didn't even make a return value. So return habitat fee per month. That should resolve it. And I think we have all our errors fixed. Name is not used. What I like to do here is create getter and setter methods for stuff that we don't really use. So we created a method for get name and method for set name, and these are automatically generated. So we fixed all the errors in Panda. Let's see if static is still needed here. Yep, we're still getting an error, so let's just add static. Static basically means that we don't have to create a new instance of the object in order to call it. So it's unusual why we're getting that here, but this is not important. So now let's run this test now that we fixed all our errors. And we get a failure. We get that expected 105.263, but was 105.263.157.894.736.84. Now, as you can see, this is a problem because we want it to pass, and we want it to be the exact value we expected. Because in real life, it'll be a waste of time to put all of these numbers in. So we need some way, and let's just make it 105.26 because this is money. So we're calculating monthly maintenance fees, and we don't need 3 decimal places. So we need to fix this. So let's go back into our Panda function, our method, and let's fix this up a bit. So what I want to do is I want to use something called BigDecimal, and BigDecimal is a way to control how many decimal places are being outputted. But BigDecimal in a broader picture is very, very important for rounding exactly as you want. So when you're dealing with functions and classes in, say, like finance or stock in the stock market, or industries that require precise amounts, BigDecimal will ensure that you are getting the most accurate numbers after doing arithmetic as possible, and it gives you more control over how you want your output to look when it comes to these arithmetic equations. So we're going to implement BigDecimal. So first, let's so we have habitat fee per month. Let's do BigDecimal. Let's just call it BD equals new BigDecimal. And this takes a while to understand, but every time you use BigDecimal, you have to create a new modifier when you're converting something such as double into BigDecimal. And let's do habitat fee per month. So we're converting habitat fee per month, which is a double, as you can see here. We're converting it into BigDecimal, and this is how you do it. You do new BigDecimal in parentheses whatever you want to make BigDecimal. And now that this is BigDecimal, we can actually use the set scale attribute, which you cannot use for a double, but you can use for a BigDecimal. So that's why we can now use .setScale. And within setScale, you can look this up in their documentation, 2 is the number of decimal places we want to round it to, and rounding mode dot half up will basically round it up, just like how normal rounding is done. It'll round up if it's greater than 0.5, round down if it's less than 0.5. And we get errors that are saying, so let's fix the big decimal. We have to import BigDecimal from java.math. And then we also have to import rounding mode from java.math. And these are all showing up here. And I want to emphasize why set scale cannot be used by anything other than BigDecimal. So let's say we do habitat fee per month dot set scale, and let's do the same thing, rounding mode dot half up. And as you can see, we get an error because cannot invoke set scale on the primitive type double. So set scale is exclusive to BigDecimal. So that's what we have here. And we have BD. BD is not used, obviously, because we haven't done it yet. And what we want to do is return BD instead of habitat fee per month. But we also want it to be of type double. We don't want to make this BigDecimal because BD is of type BigDecimal. And if we return BD, we have to make this BigDecimal, which will complicate everything else. We want to keep it consistent since we're using this method in this method. So we can't combine double with BigDecimal. We have to make these BigDecimal too, so it complicates it. So instead, let's just return BD. As you can see, we get an error. Cannot convert from BigDecimal to double because this is of type double. So let's do BD dot. So this is a BigDecimal functionality as well, which is double value, and this will convert BigDecimal back to double. And that's a very, very long-winded process for something that's so simple, but it's very important to know in certain situations. So now let's run this again, and we should get a passing test because 105.26 is the same for both methods. Now let's think about this even further. Let's think about a circumstance where we're calculating the months between animal habitat expiry date and let's say we're on habitat expiry date. What happens? So the months between now and now. Let's see what happens in our Panda test. If it'll still run. We get an error, infinite or NaN. So this is something that's happening because we cannot calculate between now and now because it'll output to infinity. So let's fix this by creating a condition where if duration equals 0, so that's what's happening, right? Is that the month between animal habitat expiry date and animal habitat expiry date is 0. So if it's 0, we return 0. Else, we do the following things. And we return 0 and not 1 because if we are on the day where we no longer need the habitat expert to come in, then we're not paying $2,000 at all because we're on the day that the law has expired and we don't need the habitat expert anymore, right? So that's why we're returning 0 because the habitat expert fee is already lump sum of 0. We don't need it anymore. So now that we have that done, we can continue on and calculate the test get habitat expert fee. Or sorry, so what we just calculated here is not the monthly maintenance fees, because monthly maintenance fees is the sum of this and this and this. What we actually calculated was get habitat expert fee per month. So instead of this name, we should make it test get habitat expert fee. And note that it doesn't matter that we change the name, it'll still run, it'll still pass because this name is only for us. We're getting errors because of this, so let's fix this real quick. Test get let's call this test calculate monthly maintenance fees, and let's do double expected equals something and double actual equals something, and then assert equals expected actual, right? So let's fill these out. So Andy, so expected is what we want it to be, and actual is what we do when we actually run the method. So let's do Andy dot calculate monthly maintenance fees. That's our actual. And this is found by adding up expert visit per month plus special vet fee per month plus get habitat. So let's actually just copy this return method and do this expert visit per month plus special vet fee per month plus Andy dot get habitat. And we actually can't, well, what we can do is do expert visit per month equals, so what I'm doing right now is these variables cannot be found because this is a completely different class, but we want to recreate this as much as possible. So let's copy and paste these into this local test so that we no longer have these errors. And when we get an error here, only final is permitted, so let's just remove these private modifiers. And we've done it. We have completed the maintenance fees test. We're getting a test here. Oh, obviously it should be void. And I don't like that it's not coloring up the body. I don't know why that's happening. There's an error here. Oh, we have to create a semicolon. There we go. Okay. And we want the expected, which is 250 plus 320 plus whatever this method is. And we know that this method is working, so we can obviously use that method here, and that's the expected. And then we want it to match the actual. So let's see if that happens. And yep, we have both tests successfully passing. And that is it. We have our Panda class. We have tests that make sure that these are working as expected. And we also have our dog test and dog. We're actually having some warnings here. Let's create getter and setter for name in the dog class. So I did that, and let's see what else we're getting here. After each, before all, and after all are never used. So let's just delete those. And boom, we have no errors or warnings in our files, and we're effectively done. So what I want to do in the next video is combine the dog and panda classes and put them under an overarching pet class, and we'll find out why this is important to do in the next video rather. But just know, like, a sneak peek of what we're going to do is we see that calculate monthly financing is the same for both classes. So we want some way to combine them and not make them seem like separate methods. And that might seem very vague now, but in the next video it'll make a lot more sense when we actually do it. So dog has calculate monthly financing, and so does panda. and we want to combine them somehow within the overarching pet class using the abstract modifier. So I hope you guys enjoyed the video. I hope you guys learned a lot about the different BigDecimal, about LocalDate, about creating methods within a class, and you've gotten better at unit tests. I would recommend making these yourself, or even better, making a scenario for yourself and implementing it yourself from there, and figuring out how to, you know, how this stuff works by simply doing it yourself. But let me know if you have any questions. I'd be more than happy to answer them. And hope to catch you guys in the next video. Peace.